Namaste students, how are you all? I think you all are fine and doing good in your academics. Today in this class we are going to deal with some other properties which are left still. Yes, in the last class we have seen the properties like which are related to the multiplication of integers. There we have seen closure property of multiplication, then commutative property of multiplication, then associative property of multiplication. Yes, and before that class we have seen the addition and subtraction of closure property, then commutative property, then associative property. Okay, and before that and after these commutative property, associative property of addition, we have gone through the multiplication of integers and later we learned all these properties. And now let us go with the multiplication by 0. No need to write that multiplication by 0 on the board because we know whichever integer or whichever number you multiply by 0, the answer is, the product is always 0. Yes, so multiplication by 0, it gives 0. Yes, whichever integer it may be. For any integer a into 0 is equals to 0, that is nothing but 0 into a. Yes, so this is multiplication by 0. Yes, so here if you take some examples, minus 3 into 0, yes, of course it is 0. Any integer with 0 gives us 0 only, and if it is 17 into 0 is 0. 53 into 0 is 0. 0 into minus 42, or if you multiply minus 42 again it with 137, if you are considering, the answer is 0 only. Yes, multiplication of any number of integers with 0 gives us 0 only. That is nothing but in general for any integer a into 0 is 0 is equals to 0 into a. Yes, where a is any integer, so a into 0 is 0, or you can write 0 into a. See here, 0 into anything is 0, or anything into 0 again is 0. Yes, and also we have learned the additive identity. Which is the additive identity? 0 is the additive identity, and multiplicative identity. What is that multiplicative identity? Yes, of course it is 1. Yes, so now the last property that is left is distributive property. Okay, so distributive property of multiplication over addition. Yes, let us solve some problems on that. This distributive property of multiplication over addition, distributivity of multiplication over addition. that is equals to minus 4 into 8 minus 5. If you are writing this is wrong. It is understood that you have to subtract 5 from 8. ಹೌದು ಇದರೊಳಗ 8 ಒಳಗ 5 ನ ಕಳಿಬೇಕು. ಡಿಫರೆಂಟ್ ಸೈನ್ ಇಲ್ಲಂದ್ರೆ ಕಳಿಬೇಕು. 8 ಒಳಗ 5 ಹೋದ್ರ 3 ಬರ್ತದ. ದೊಡ್ಡ ಸಂಖ್ಯೆಗೆ ಏನು ಸೈನ್ ಐತಿ ಅದನ್ನ ಹಾಕ್ತೀವಿ. ಆದ್ರೆ ಅದನ್ನ ಹಿಂಗ ಬರಿಬಾರ್ದು. This is wrong. This should not be written. Okay. So now see what is that? Minus 4 into this is 8 minus 5 is 3. Bigger number is carrying negative sign, so it is minus 3. What is minus 4 into minus 3? Minus into minus is plus. 4 3s are 12. Okay. So now what is RHS part then? RHS is A into B plus A into C, where A into B plus A into C. See? A into B plus A into C. Yes, that is equals to. So first solve this, then solve this part, then add those answers. Minus into minus is plus. 4 8s are, it is of course 32. Yes. Then minus 4 into 5. So it is minus. Only one negative sign. So answer is minus. It is plus of minus. 4 5s are, yes of course it is 20. Yes. That is equal to 32. Plus into minus. This bracket is nothing but into. Plus into minus is minus 20. Yes. 32 plus into minus is minus 20. Now 32 minus 20 is of course 12. Yes. This 12 is equals to 12. When these things are equal, then we say that these two are also equal. Yes. So now that implies, what it implies? It implies that minus 4 into minus 8 plus 5 is equals to, that is equals to minus 4 into minus 8 plus minus 4 into 5. That is nothing but A into B plus C is equals to A into B plus A into C. Yes, this is right. In general, what we can say? In general, for any 3 rational numbers, for any 3 integers, for any 3 integers A, B and C, for any 3 integers A, B and C, A into B plus C is equals to A into B plus A into C. Yes, so this is what? This is the distributivity of multiplication over addition is true for integers. Yes, we can conclude here. Distributivity of multiplication over addition is true for, it is true for what? It is true for integers. Yes, that is A into B plus C is equals to A into B plus A into C. We'll take one more example, then we'll understand it clearly. Okay. So now the next example, let's consider some more examples here. If I'm giving some work on this for you people, you have to solve in the same manner. Yes, are you getting me what I'm saying? Here, consider 5 minus 2 and minus 3, where 5 minus 1 minus 3 are 3 integers. A is 5, B is minus 2 and C is minus 3. Okay, so now it is A into B plus C. See how I am saying? A into B plus C is minus 3. Yes. You have to write them as equation only. Now you have to solve both the sides. Getting? Let us solve this. See, 5 into minus 2 plus minus 2 plus of minus 3. See, minus 2 plus into minus is minus 3. That is equals to 5 into minus 2 plus into minus is minus 5 2s are 10. Are you getting? Only one minus sign, so minus 5 2s are 10. Plus of plus into minus minus 5 3s are 15. Yes? Is it clear? 5 3s are 15 minus as it is. Now 5 into minus 2 minus 3. Same sign, both are carrying same sign. So add. Yes? Same sign, add. 3 to 5. Put the same sign. Yes? Minus 5. That is equals to minus 10 plus into minus 15. 1 5. 15. Okay. So now 5 5s are 25 minus. So minus 25 plus into minus is minus 5 5s are 25. That should be equal to minus 25 only. See whether this minus 25 equal to minus 25 only. Both are carrying same sign. So minus 10 plus 15 25 minus 25 is equals to minus 25. Therefore a into b plus c is equals to a into b plus a into c. In this manner only you have to solve all the questions if it is given. Check whether for the integers 5 minus 5 minus 3 the distributivity of multiplication over addition is true or not. Yes? So in this manner only you have to solve. Okay? Yes. Now let us take some other examples of distributivity of multiplication over subtraction. Okay? Multiplication over subtraction. See the spelling of subtraction. Yes, U-B-T-R-A-C-T-I-O-N. Subtraction, not subtraction. That S-U-B-S you used to write. That it is not S-U-B-S. It is wrong. S-U-B-T-R-A-C-T-I-O-N. Subtraction. So what is this distributivity of multiplication over subtraction says? Yes, of course it is A into what? In the case of addition, we have considered it as B plus C. Yes? So now subtraction means B minus C. B minus C. That is equals to, it is A into B minus A into C. Yes? Now we have to check whether this LHS is equals to RHS or not. Let us check. Consider 1 minus 2 and 4. We have considered three integers as 1 minus 2 and 4, where A is 1, minus 2 is B, 4 is C. Okay, let us substitute in LHS part first. A into B minus C. A into B minus C. Yes, that is equals to, now see, 1 into, because this is in the bracket, first we have to solve this, same sign, add, 4 2s are, it is 8, right? When you add, you have to put the same sign, so 1 into minus 8, that is equals to minus 8, yes? Now, this is LHS part, then we have to move for RHS. It is not 8. You should not multiply. Sometimes it happens that you are going to multiply these two. No. When both are carrying same sign, add. 4 plus 2, it is 6. Yes. So this is 6. Yes. So 1 6 it is 6 minus 6. Are you ready? Now 1 into minus 2 is minus 2. Minus as it is. 1 4s are 4. Same sign. Add 4 plus 2 6. Put the same sign. Minus 6 is equals to minus 6. Therefore these two are equal. Yes. When the things are equal to each other, then these are also equal. That implies 1 into minus 2 minus 4 is equals to, that is equal to 1 into minus 2 minus 1 into 4. A into B minus C is equals to A into B minus A into C. Yes, are you getting? So, what we are going to conclude here? In general, for any three integers, A, B and C, A into B minus C is equals to A into B minus A into C. Yes, so here it is clear that distributivity of multiplication over subtraction is also true for integers. Yes, concluded. Distributivity of multiplication over subtraction is true for integers. Yes, it's clear. So, A into B plus C is equals to A into B plus A into C, and A into B minus C is equals to A into B minus A into C. A into B minus A into C. If it is plus, A into B plus A into C. It's easy. Yes? Okay. So, let me take one more example for this. Here, I am going to consider all the three as negative integers only. And consider minus 3, minus 4 and minus 2. See, A, B, C. Right? We consider three integers as minus 3, minus 4 and minus 2. So, for this general statement, we have to substitute these. It is A into B minus C. See how I am writing. A into B minus C is equal to, that is equal to A into B. A into B. Don't forget to write that minus sign, negative sign. A into B minus A into C. Yes? A into B minus A into C. So here what we have to prove? We have to prove that LHS is equals to RHS. Yes? Let us get the answer. Minus 3 into, see, minus 4 as it is, minus into minus is plus 2 is equals to minus into minus is plus 3 4s are 12. Yes, here you are multiplying, so no need to write minus sign. Yes, when you are multiplying, minus into minus is plus. Yes, now minus as it is I will write minus into minus is plus 3 2s are, this is 6. Yes, now minus 3 into, see, different sign, subtract. 4 minus 2 is 2, bigger number is carrying negative sign. Yes, satisfies the distributive property. Yes. Is it clear? So if some questions are given like this, check whether the distributivity of multiplication or subtraction is true for integers or not. So after getting the answer, when LHS is equals to RHS, you must get LHS is equals to RHS because the general statement says the same. LHS is equals to RHS here. If you are not getting LHS is equal to RHS, so somewhere you are wrong. Check it again. Okay? Yes. So after this, now let me move with the how to make the multiplication easier. Yes. Making multiplication easier. Making multiplication easier. Is multiplication easier? Yes, of course. Is multiplication easier? Yes, it is easier. But still, how we are going to make the multiplication easier? Is there any method to make the multiplication easier? Yes, of course it is there. Whatever the properties we have learned till now, the commutative property, associative property and the distributive property, these makes multiplication easier. Okay, so now let me take an example. Consider, yes, if you are taken minus 25 into 27 into 4 is there. Let us consider minus 25 into 27 into 4 is there. Without actual multiplication, can you find the product of these? Yes, you can find. Without actual multiplication, I am saying. With actual multiplication, how are you going to multiply? You can multiply minus 25 into 27 and you are going to get some answer as P. With that P, you are going to multiply 4 and you are going to get the answer as Q here. Yes? You are going to get, yes, this is the actual multiplication. Okay? But now, without actual multiplication, how are you going to get the answer? There are two methods. Yes, I will say you. See, minus 25 into 27 into 4 is there. One method, what you are going to do? Minus 20, once you are going to multiply minus 25 with 27 and after getting the answer, you are going to multiply it with 4. One method. See, minus 25 into 27, yes, it is minus 625. This let us consider. Minus 625. Then it is into 4 is there. Yes. That is equals to. Is it minus 625 only? Yes, let us check. Minus 25 into 27 is there. Yes, it is 675. Minus 675 into 4. After finding minus 675 into 4, now you have to multiply these two. It is how much? Yes, of course it is minus 2, 7, 5, 0. Is it so? See, 4 5 yes, it is 20. Yes. Write it again. It is minus 675 into 4. 2700, so that is equals to minus 2700. Sorry, minus 2700 is the answer here. So this made little difficult. I made little difficulty because sometimes when the numbers are like this, it is sometimes it is difficult, but we can make it easier in this way. So now I'll find the answer by using another method. See, minus 25 into 27 into 4 is there. Yes. I will arrange this as minus 25 into 4 into 27. See, minus 25 into 4 into 27. Here, I have rearranged the numbers. So, which property I am using here? Yes, I am using the commutative property, or you can call this as Yes, here you can write distributive property. Yes. Now, how to find the answer? 4 into 30, yes, it is 120 plus 4 6 it is 24. Yes, 4 6 are 24. So the answer is, it is 144. 36 into 4, if you find the actual multiplication, 36 into 4, it is 144. Are you getting? So this is the way where we are going to use the properties which makes the multiplication easier. So in the next class also, I am going to take some more problems from this, then we will understand how the multiplication can be made easier by using the properties. Okay, thank you.